Welcome to this explainer, the high-stakes gamble, why humans lost their fur. You probably look in the mirror every single morning and don't give your bare skin a second thought. Millions of us spend a literal fortune on shaving and hair removal. But to evolutionary biologists, the real mystery isn't why we have hair, it's why we are so incredibly hairless compared to the rest of the primate family tree. And this isn't just some boring biological trivia. Shedding our body fur was actually a thrilling, high-stakes, and incredibly dangerous survival story. It was an evolutionary gamble that pushed our early ancestors to the absolute brink.
So let's dive into this. What was the most dangerous evolutionary risk our species ever took? When we think of evolutionary advantages, we usually think of gaining something, right? Sharper claws, bigger brains, stronger muscles. But what if the riskiest move we ever made was actually losing our primary layer of protection? Stripping away our thick coat of fur as we moved out of the safety of dense forests and onto the rugged exposed African savanna completely changed how we interacted with the world.
To understand how we actually did this, look at this comparison. We have the ancestral ape with dense, thick, terminal fur covering the body versus the modern human who has a similar follicle density but fine, invisible, miniaturized hair. Yeah, it's a massive misconception that humans just don't have hair. We actually share almost the exact same density of hair follicles as chimpanzees. The difference is all in the hair itself. Scientists discovered that a specific inhibitor protein called DKK2 acts like a biological brake. It blocks a signaling pathway in our skin, essentially stopping the growth of thick, visible hair on most of our bodies.
And that brings us to vellus hair, fine, miniaturized body hair that replaced thick ancestral fur, giving early hominins a naked appearance. This genetic shift fundamentally transformed us into the naked apes. And honestly, it set the stage for a monumental shift in behavior. It's what allowed our ancestors to confidently step out of the shaded, cool canopy of the dense trees and migrate straight onto the sweltering, sun-baked, open African savanna.
But why on earth was being naked an advantage on a boiling savanna? It all comes down to persistence hunting. This was a technique where early hominins chased prey over long distances in sweltering heat until the animal collapsed from exhaustion. Picture early bipedal humans tracking prey over vast open distances in blistering heat. We definitely weren't faster than the animals we hunted, but we had a secret weapon. Because we lost our fur, our bare skin allowed us to sweat and cool down rapidly. We could literally run a gazelle until it collapsed from heat exhaustion, all while keeping our own internal body temperature perfectly stable.
And the crucial point here is this number, 10. To make this hunting strategy work, our biology underwent a massive upgrade. Humans have a staggering 10-fold higher density of eccrine sweat glands compared to chimpanzees and macaques. We didn't just lose our hair, our bodies actively compensated by expanding this network of millions of sweat glands. We basically became the ultimate evaporative cooling machines. We had extreme endurance in the heat of the day, right when prime predators and prey alike were absolutely forced to rest in the shade.
That explains the why, but it leaves us with this fascinating biological detective story. Exactly when did our ancestors lose their protective fur? The fossil record is notoriously bad at preserving soft tissues like skin and hair, so scientists couldn't exactly just dig up a bald hominin fossil. Instead, they had to turn to one of the most bizarre and kind of gross clues in the natural world to pinpoint our timeline. They looked at the genetics of parasites, specifically lice.
Now, what's really interesting here is that humans are unique primates hosting two separate lice zones, head lice and pubic lice. Chimpanzees only have head lice, gorillas only have pubic lice, but we have both. And here is the absolutely wild twist. Genetic analysis reveals that our human pubic lice are actually related to gorilla lice, not the lice of our closest evolutionary relatives, the chimpanzees. No way, right?
So how did that happen? Well, lice need direct physical contact to switch hosts, perhaps from sleeping in a gorilla nest or scavenging. They can't fly or jump. Research suggests early hominins likely picked up these specific parasites about 3.3 million years ago. But here is the real key to our hairless timeline. For these two distinct types of lice to survive on a human body without totally outcompeting each other, they needed separated habitats. This proves that 3.3 million years ago, our ancestors had already lost their body fur, leaving behind these isolated islands of hair on the head and groin.
So we know we were mostly hairless over 3 million years ago, but this brings us to the terrifying trade-off of this whole gamble. Look at the daytime advantage. Sweating prevents fatal heat stroke on the savanna. Versus the nighttime danger, severe nocturnal hypothermia at high altitudes. Losing fur gave us that massive daytime hunting advantage, but the African savanna drops to freezing temperatures at night, especially at higher altitudes. Without a fur coat, our ancestors were suddenly exposed to freezing to death the second the sun went down.
Let's break down the deadly dangers of hairlessness: severe nocturnal hypothermia, extreme UV radiation exposure, and high injury risk from scrapes and cuts. Walking this rugged landscape completely naked was incredibly dangerous. You have the fatal risk of freezing at night. Then, stripping away fur exposed our bare skin to extreme, relentless UV radiation, leading to severe burns and the destruction of folic acid, which is vital for reproduction. And third, without thick fur acting as armor, the risk of deadly infections from everyday cuts and thorny bushes skyrocketed. This was an evolutionary bottleneck that could have easily wiped us off the map.
And this timeline brilliantly illustrates just how long we were vulnerable. 3.3 million years ago, pubic lice split from gorilla lice, meaning our body fur was reduced. Around 1.2 million years ago, the MC1R gene mutation sweep happened and dark skin evolved. But look at this last one. 70,000 to 190,000 years ago, body lice split from head lice, meaning clothing was invented. That gap is staggering. That means for millions of years, our ancestors were wandering the earth essentially naked, battling the intense elements without any artificial fur.
So how did we survive the brutal sun for millions of years before clothes? The MC1R gene selective sweep replaced a physical fur shield with a chemical melanin shield. About 1.2 million years ago, this massive genetic shift favored the production of eumelanin, resulting in highly pigmented dark skin. Essentially, our biology stepped up. Evolution replaced the physical shield of our lost fur with a chemical shield of melanin. This pigmentation was absolutely crucial. It acted as a natural built-in sunscreen to protect our newly bare skin from catastrophic UV damage. Let's move on and see how surviving the gamble builds on itself. Step 1, biological adaptation, meaning sweating and pigmentation. Step 2, cultural shelter and controlled fire. And Step 3, the invention of clothing. Biology alone couldn't save us from those freezing nights. To survive the cold, our ancestors had to rely on their brains. We took behavioral leaps, controlling fire and building cultural shelters to artificially heat the night. And finally, the ultimate fallback system was the technological invention of clothing, which allowed us to completely bypass our biological limits and migrate into freezing climates all over the globe.
And remarkably, parasites once again give us the exact timestamp for that final step. As this quote notes, lice evolution tracks the invention of clothes. When humans finally started wearing animal hides, a brand new habitat was created. A subset of our head lice migrated down into our garments and evolved into a totally new species, the human body louse, which feeds on skin but lives specifically inside clothing. DNA analysis shows this divergence happened between 70,000 and 190,000 years ago. That gives us the exact window of when humans finally engineered artificial fur.
So, all things considered, could our gamble of losing hair have easily led to our extinction? Absolutely. 100%. Shedding our fur to become endurance hunters was a brilliant daytime strategy, sure, but without the subsequent evolution of deep skin pigmentation and the intellectual leaps to harness fire and craft clothing, the naked ape would have frozen or burned to death long before conquering the globe. So the next time you look at your bare arm, realize you aren't just looking at skin. You are looking at the ultimate proof of how incredibly close our species came to failing and how our minds literally had to evolve to save our biology. Thanks for joining me on this explainer. I'll see you next time.